aerospace and defense manufacturing,
machines and automation,
additive manufacturing,
smart manufacturing,
the global manufacturing economy.
Hello and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. I'm your host, Steve Plumb, Editor-in-Chief for SME Media. Please remember to like and subscribe to get new episodes delivered to your feed each week. I'm pleased to be joined today by Gabriela Ciocarlie and Curtis Taylor from the Cybersecurity Manufacturing Innovation Institute, or CyManII for short, which is part of the Manufacturing USA, as well as Vinh Nguyen, who is an assistant professor of mechanical and aerospace engineering at Michigan Technological University, which is located in Michigan's Upper Peninsula. Welcome to the show, everyone.
Thank you.
Great to be here. Happy to be here.
So not surprisingly, the focus today is on cybersecurity and more specifically, how small and mid-sized manufacturers can better prepare and defend themselves against potential vulnerabilities and attacks. So to this end, Michigan Tech worked with CyManII on a recent project. But before we get into the details, I was hoping that Gabriela and Curtis could give us a brief overview of CyManII for listeners who may not be as familiar with the organization.
Sounds great. Thank you, Steve. Thank you, everyone. I'm very glad to be here. I'm Gabriela Ciocarlie, and I'm the acting CTO for CyManII. So who is CyManII? CyManII is one of the manufacturing institutes. So our focus is mainly on cybersecurity. We are the only DOE-funded institute focusing on cybersecurity for manufacturing. We are an institute that has as partners universities, national labs, and industry partners, of course. And for the past years, we've been focusing on research and development, but also on educational and workforce development for manufacturing. One other important thing to add is that we are one of the only institutes that is focusing on TRL 2 to 6. So that means that we also have a focus on foundational research. And I will invite Curtis to say more also.
Thanks, Gabriela. We're focused on the low-level TRLs, and we're also public-private partnerships. So most of the work that we do and the funding that we receive through DOE is made for outreach and working with industry partners to help better secure and create new innovations in manufacturing to really strengthen and bolster moving forward U.S. manufacturing. So how do we, create new opportunities for manufacturing in the United States, and how do we do so making sure that it's secure?
And Gabriela and Curtis, what are the TRLs?
Technology readiness levels. So they are defined with respect to where you are in the process of developing a particular technology. So TRL2 is early on, or it's more on starting from an idea or research idea. And then TRL6, it means that you already tested in an environment that is representative, your technology, but then a technology that really becomes a product has a higher TRL9, which means that it's a full product that can be adopted by industry and the community at large.
So, Vin, that's a good segue to talk a little bit about Michigan Tech. Even though we're both in Michigan, Michigan Tech is about as far away from Detroit as you can get. It takes quite a while to drive up there. But tell us a little bit more about the school and also regarding the TRL, where you stood in that process.
So Michigan Tech is a R1 research university. We recently had a little over $100 million in research expenditures. We're generally focused on engineering, technology, and computing disciplines. We are very far up north. So the way I like to say it is Detroit is actually closer to DC than Detroit is close to Houghton. So we're way up in the U Peak and about 290 inches of snow as a record there. In terms of TRL, Michigan Tech spans a wide array of research portfolios in that area, ranging from very low TRLs, one particularly funded by National Science Foundation, all the way up to much more higher industry ready TRLs that we support.
So being that you're, a technology-oriented university, I would imagine that cybersecurity is something you're very familiar with.
Yeah, that's something that we work and do pretty well. We're actually designated as a National Academy of Cyber Excellence by the NSA, both for education and for research. So we do value cybersecurity. We of course have red team reviews. Red team competitions. So we definitely value cybersecurity, not just for education, but also for working with industry as well, whether it's working with industry to determine best practices, so more on the higher TRL level side, or working more on developing new cybersecurity technologies on the lower TRL side, for instance, with federated systems.
So Gabriela and Curtis, I'm sure you can speak to the fact that even very advanced and highly technical organizations still have a problem with cybersecurity and have to combat it every day and find new ways to thwart such efforts. Can you talk a little bit more about the growing threat of cyber attacks, especially in the manufacturing industry?
Sure. Manufacturing industry is actually becoming more and more a target for attack, and the consequences when we talk about manufacturing can be significant. Imagine that attackers could target the production of critical components, and that can then be impacted at the next level in a supply chain. Imagine that you have a motor of an airplane impacted, right? Then later on you can see the consequences while the airplane is operated. So manufacturing is extremely important when we talk about cybersecurity, and of course cybersecurity is not an easy task, and there are attacks that are evolving all the time, and specifically the attacks that are stealthy and the ones that are particularly harder to detect with technologies that might focus more on the IT side. So that's why CyManII is focusing on attacks that are coming on the OT side. So what are the types of manipulations that an attacker could introduce from the design to the manufacturing, and also even in operational times as well. So we are trying to cover the full spectrum. And then when we talk about the small and medium manufacturers, for them the task is even more difficult, right? Because being a small organizations, they do not have the means, the economical means to have sophisticated capabilities. So that's exactly where we are trying to help, to have technologies that are relevant for everyone, including the small manufacturers.
So then how did you become aware of CyManII and what they're doing and to eventually work with them?
So I've been part of the Manufacturing USA ecosystem for a while now, so I'm aware of a variety of Manufacturing USA institutes. And my interaction with CyManII actually first started with this industry use case project, particularly focused on secure digitalizations for SMMs here. And so we ended up working with CyManII, had a very great experience, learned a lot from this overall project, and yeah, I guess the rest is history, as they say.
So, Steve, shall we say that we had called for proposals, and Vin's project is one of the 10 projects that have been selected as part of the call for proposals, and we are very happy to working with Vin and having all the progress done by that project.
What was the call for proposals? What were you looking for?
So we had 3 different areas of focus. One was focusing on controllers. Another one was focusing on secure digitization. And the third one was focusing on additive manufacturing. And the goal was to have projects that were partnering with the industry and show a particular capability and also leverage our technologies, the CyManII technologies that were already available for our partners. And I'll let Vin say more about that.
Yeah, so our specific, so we responded to an RFP, that RFP by CyManII, and we were focused on the secure digitalization use case, where the particular point of that use case was to digitalize small manufacturing business there. And we partnered with 4 other organizations. So we partnered with NuVocus. They make composite rebar. They're actually located in the Upper Peninsula itself, in the town of Opmi. I think it has maybe about 100 people populated there. So you go to the end of the earth, which is Houghton, and then you go a few miles up. And then we also partnered with Automation Alley. So they're a nonprofit based in Michigan, focused on working with small to medium manufacturers. We also worked with Corsia. So they're a startup actually based in DC, where they work on securing OT systems there. And then we also worked with SME as well. And so that's, we formed the team and then went to submit the proposal, kind of showing this is how we would plan on demonstrating and CyManII's technologies, and the ultimate product of that would be a blueprint that would help small to medium manufacturers kind of have a getting started guide to see both the benefits and introductory information to CyManII's solutions.
That sounds like a formidable team there that you've assembled, and definitely qualifies as at least the size of the town as a small and mid-sized organization. So as part of the project was on energy use, how did that factor into it?
Yeah, so NuVocus creates composite rebar. And composite rebar, just generally when fiber reinforced composites, they have to be often cured. And so curing it fundamentally is you put the carbon fiber or glass fiber into an oven, then you heat apply a heating cycle to that material, and it hardens. So you kind of think of it kind of like when you have glue and you apply heat, it actually hardens. And so you get the resin curing in there. So as you can imagine, when you do the heating cycle, that's one of the more direct expenditures of energy there. And it's also a process that can be made more efficient with various heating cycles, how you do quality checks, quality controls. And it's also ripe for digitalization as well. So you can get a lot of information from that. It's actually a very interesting scientific process as well. I've actually done work in modeling partial differential equations for this specific resin curing process. And so there's just a lot of information and a lot of potential to really optimize and make this process more efficient, which in that case would result in cost savings, material savings, energy savings, so on. So that was kind of the particular process impetus for demonstrating CyManII's technology in terms of digitalizing securely.
And I would imagine the digitalization part is where the cybersecurity concerns come in. How did you go about protecting that?
Yeah. And so the first part was digitalization. So the first was getting the information out from the queuing system. And then once we got that out, we started implementing CyManII solutions for this. And so we did the digitalization. Then we implemented security. We also implemented Corsia's security protocol, which helps protect against unauthorized users. And by implementing CyManII solutions, we were able to securely enact traceability throughout the process. And that's a big part of this particular queuing process is traceability. You can imagine material science, particularly with composites, is a lot of mixing, matching materials, and also chemical reactions there. And so by being able to securely determine traceability, you could then determine something. For instance, if a malicious hacker came and tried to overload the bandwidth on the curing station such that the cure temperature wasn't able to achieve as high, we were able to securely protect against that. Or if someone came in and made the oven temperature run higher than it was supposed to, we'd be able to detect that and also kind of protect against what would be not just material waste, but also energy waste by running at higher temperatures than they're required by the cure cycle.
And does traceability apply to the supply chain as well then?
Yes. So that also applies to the supply chain. So you have the resin lot numbers, the fiber lot numbers. So it applies both before the curing process. Obviously, you have to get all your suppliers. And then after the curing process, that's actually one of the close to final steps in the process, and then sending it out for distribution.
So Gabriela and Kurs, I imagine that there is a kind of a combination of best practices that you try to help companies adopt, but there would also be unique features for each use case. How do you go about working with a team like this, and what's the process and timeline like?
So in general, there are so many facades to this question. So let's start with one thing. The way we work closely with all our teams is we have an agile process where everyone is participating in sprint efforts. So 3 weeks of sprint work, and then we have sprint reviews. And we also meet regularly every week as a team within the areas, right? Within the 3 areas that we were mentioning earlier: controllers, secure digitization, and additive manufacturing. So we have a nice way of interacting across teams as well. And having the sprint reviews gives us the ability to analyze the work of each other and provide feedback, and we get feedback from the institute in general, and also particularly from our industry partners. So that's one thing. Another aspect that I will invite Curtis to talk about more, we have an infrastructure, a secure R&D, research and development infrastructure that enables us to access all our different equipment and everything so that we can collaborate across our federated test beds and our technologies. And maybe Curtis wants to say a little bit more about SRDI.
Yeah, so the secure research and development infrastructure is one of the early foundational things that we worked on as an institute to try to prep for working with organization and entities like Vinh and his team and others. We had to kind of come up with a common ground for everyone to be able to do not only manufacturing research, but do that securely and in a connected fashion. So that's where we came up with what we call SRDI. And it really helps enable the agile aspect that Gabriela is talking about by providing the common area where, everything from code to data to documents. Everything can be done more securely in that fashion, so that not everybody's running around with everything on their computers, and if one gets compromised, everything goes out the window. So yeah, we've worked really hard on that, and I think that's given us some good relationships with manufacturers, showing that we take working with them very seriously, and it's also kind of lowered the bar to entry. Whether you're a large manufacturing OEM with your own R&D infrastructure that you're working on, or you're a small medium manufacturer that doesn't have all of this infrastructure ready to go, SRDI provides that kind of common playing field where everybody can get together. So a lot of the things that Vin and his team did were done in that infrastructure, and it also allows that replication, so that we've done it in one setting of SRDI, we can now quickly replicate that in other areas. So if another organization comes along and says, "Hey, I'm interested in some of those innovations that Vin and his team developed," the infrastructure approach we've taken makes it very easy to replicate and apply that into a new area, to a new manufacturing domain.
So you mentioned that SRDI was one of the early things that CyManII put together. I forgot to ask both Curtis, you and Gabriela, how long you've both been with CyManII?
I've been with CyManII from the beginning, and I believe, Curtis, you were there from the beginning as well.
Yep, we were there at the early inception of the thought planning and the vision making, and that was a very long and well thought out process with a lot of team members from across the country, a lot of organizations. So it's been a very, very fun journey.
So you both have a great perspective on the topic, and just wondering, what some of the things you've learned over the years, and what some of the new tools are that you're working on.
At least from my perspective, one of the, I think, really unique things, particularly within CyManII, that we have that maybe not other institutes have readily available, is the intersection of a lot of experts in different domains. So CyManII is not just cyber experts, and it's not just manufacturing experts, but it's a lot of different experts brought together. And so we have facilities in which we can do manufacturing research and development, such as the manufacturing demonstration facility at Oak Ridge National Laboratory in Tennessee. We have the cyber for manufacturing facility in San Antonio. So we have places where people actually live and do manufacturing day to day, and we intersect them with cyber. And that was a very early concept that we understood, that you couldn't have one or the other. You're not going to be able to make the impact you want to have without having both of those people in the same room, and having facilities like that are fully operational, essentially 24/7, and being able to bring those people and have them collaboratively working together. That's absolutely key to making success happen in this area. You can't do it without the whole village.
Right. And working with Vin and his team, what were some of the biggest challenges and risks that you identified and helped them overcome?
I would say that I would start with the extraordinary exposure that we had. So by working with different teams, we encounter new requirements. So I think Vin's team in particular, with their particular use case, open up different ways in which the cyber physical passport, for example, could be used. So I think one of the closer interactions that we had together was to look at ways in which we can design the use of cyber physical passports for his purposes, and that was an excellent experience. I would not call it challenging, but I would call it it allowed us to look at new ways in which we can leverage the CPP, new scenario, and that was beneficial for us as well, because we just expanded the use cases that we can cover with CPPs.
And I would also add on to that by saying that, then we were very lucky in working with his team in that, he had close collaboration with an actual SMM, right? And that SMM has a very unique process and something that they want to protect from an IP perspective, right? So they have real data that they want to protect, but they also they want to digitize and they want to become more secure. And so then helping work through where those delineations are of what can be easily open, shared, and worked on and what can't allowed us to kind of very clearly put some information within our infrastructure, but also know the information that we don't need to have in our infrastructure. And so him acting as that kind of translator with the SMM and the actual R&D helped us better understand our requirements and kind of what we can do on the SRDI side, how we can better help those engagements and allow him to work more closely with that manufacturer while not necessarily having to share all of their data.
Vin, you want to add anything to that?
Yeah. I mean, I thought that overall it was a great experience. I think that one for us, right, we were very new to a lot of these CyManII solutions, where, for instance, Curtis and Gabriela had and formulated, right, and obviously are very familiar with these solutions. So I think that for us, one thing, part of it is almost maybe in a sense of like, oh, okay, how much is there, right? Is there a lot to grasp, right? Manufacturing, cybersecurity, the intersection of all of those, which is actually a testament to what CyManII does and the breadth and depth of the solutions that it provides. So I think that, for us, one thing we were a bit nervous about was ramping up, getting acclimated with CyManII's solutions without being as familiar with CyManII when the project started, at least to this depth. But working with Gabriela and Curtis and also Paulo, so he's one of the architects of Seek, was a really great experience. And CyManII does a really good job at helping people get onboarded with those solutions there. So I think from us, that was kind of the kind of biggest adjustment, but it was actually done quite well, I would say, in my experience.
So, Curtis, I believe you mentioned cyber physical passports, and I know there's several aspects of that, kind of going through the product lifecycle, product design, machine, and record. But can you elaborate a little bit more on exactly what a cyber physical passport is and how it applies to the different areas?
So I can give my perspective, but this is Gabriela's baby, as I would say. So she's been on the cyber physical passport journey for a long time. So I'll give my quick spill, and Gabriela, I think, can go into a lot more detail on it. But I think the idea, kind of as the name implies, you think about you having a passport as you go to different places. The passport itself has a lot of security built into it, and as you travel to different regions and different places, right, you get your stamp as it goes along, right? Your official thing that says you've been somewhere, when you came in, when you left. You kind of attach that notion to a part all the way from source to final product, meaning potentially assembly of our products. And I think being able to track that and do that securely across the entire life cycle of development is what we're going after here. And I think where it's differentiated from other ideas like this idea of tracking information, is that we really try to integrate the cyber plane, the energy plane, as well as the physical plane. So we pull in a lot of information into the passport. It's not just general high level information about a part. It's anything from telemetry data to material composition to information about the machine that manufactured the part. Could include information about the operator running the machine. So it includes a lot of multi-dimensional data, which, if we really want to get to that end game of having secure trust in a part that we've received and across the supply chain, you really have to include more than just some of the basic data that I think other concepts similar to this look at. And I'll let Gabriela expand on that.
Thank you, Curtis. Yes, so Curtis gave a great presentation on this, but I would add that there are also verification capabilities integrated into the CPP framework. So it's not only about collecting all the data and doing that, collecting all the provenance data and doing that in a secure way, but also including verification capabilities. As we were saying earlier, we are building the passports from the design to the production and in operation, and we do that across the supply chain. And any kind of verification that is supporting along the lines will also be part of the cyber physical passport of the final product. So like this, you have the ability to answer different questions. You have the ability to verify the integrity of a part across the supply chain. You have the ability to say these are the types of verifications that have been done. This is the formal verification that has been done for a particular product. So we have the ability to also answer questions at a higher level for the supply chain, and beyond security. So we are expanding the work to give us answers with respect to security, but also for productivity and efficiency, and even for compliance questions, right? If you have certain requirements for compliance, you can also leverage our CPP framework to answer compliance questions. So all this framework is operating, again, on top of a lot of different types of passports. We have the design passport, we have the product passport, we have the product item passport. All of these are kind of saying that, hey, the design, this is the design that I'm using. These are the verifications that I've done for that design. These are the products that we are building, and we define the product with everything that is attached to it. And then when the manufacturing process is happening, every manufactured part will have its own passport linked to the design. One interesting thing that we discovered while we were building the infrastructure is that we have a unique view of also linking the software bill of materials, the SBOMs. Now we have the ability to link SBOMs across the design, and the production areas, and also in operation. Now we can say that if you build a particular program, you now know what software was used in the design. You now link that software to the software used for manufacturing machines that produce that particular part. So we can have a better view in terms of the types of security questions that we can answer, because attackers can be very versatile, and then they can introduce small effects in the design via the software of the that is used for design. They can introduce something during the manufacturing, and there can be a cumulative effect based on those. We can link the software across all these different stages of the life cycle of a part. So the CPP, again, gives us all these different views that other systems cannot do.
Yeah, from a development standpoint, I know it's critical for various constituents to have access to that software, but it does open up a lot of potential points of entry for bad actors. Another component I know that is part of the blueprint is CEIQ. How does that fit into this?
It fits very well, as Vinh was mentioning earlier, right? He's been working on CEQ by looking at the energy efficiency. So the CEQ framework gives us the ability to provide ROI analysis. So what is the return on investment for secure implementations of digitization technologies? And we do that from two perspectives, with energy savings, but also the risk reduction through security capabilities. So the CEQ approach, I will let Vinh tell a little bit more again how they use it in the project. But the CQ at the energy level, it's all about the energy savings and the efficiency improvement that can be achieved by digitization. And then with the cyber layer, it's a matter of how you reduce the cyber risks via employment of different security capabilities like the ones that we have inside CyManII.
Yeah, so kind of to specify some more about how CIQ, Seek was used in the project. So we had what Gabriela said, the energy layer and the cyber layer. So the energy layer, we started with baselining, saying that this composite curing process expends a certain amount of energy. Generally, you do it per mass. In a more applied situation, you could just say the overall energy usage. Then you go into improvement planning, saying, okay, this is what I use. Now, what can I improve it to? You also then look into cost and risk analysis. So this is how much I have to spend or invest in order to obtain that improvement, and then going to energy realization and savings. And then for us, particularly this project, it wasn't just necessarily just the energy used, it's also the efficiency, right? If you're digitalizing and then you're able to get a much better understanding of your process, you can, for instance, run things faster. You can use less materials. So we also looked at the energy layer in that aspect to save and improve the process in a more general efficiency. And then with the cyber layer, what we did is that we did baselining, conducting vulnerability assessments when you're digitalizing that particular process. What are the possible assets and threats and impacts? And then doing it once again, improvement planning. And cost and risk analysis. So here's the investment that you would have to make to secure this process. And then also the realizations and savings from securing that digitalization as well.
Yeah, it's interesting that you're able to quantify and kind of calculate an ROI for the energy savings, through improved efficiency. But it sounds like you're also trying to at least you look at some of the potential benefits and how that affects the cybersecurity side of it. I know that the goal of working with CyManII is to prevent such an attack, but can you really quantify it beyond peace of mind?
Yeah, and that's something that's always interesting about cybersecurity and cyber insurance as well. It's you don't know what you're saving until something bad happens, and so particularly in a very practical real world, a practical real world environment. I've published papers in this that are more maybe academically inclined, where you can quantify the likelihood of an attack, and then from there you can actually estimate a savings from there if you have that likelihood. Of course, if you ask me what's the likelihood of Nuvocus getting hacked, that's a very difficult question to answer and to validate there. And so what we ended up doing was actually saying, like, okay, we have a range of likelihoods. That range was not based on necessarily any prior data. It's from 100% to 0% likelihood that you're going to be attacked annually. And then what you can do from there is you can plot your risk savings. So for instance, if my baseline is I have a 0% likelihood of being attacked, then maybe you would actually lose money. If you had a zero, now obviously 0% is not possible. You wouldn't make any money if you protected against something that doesn't exist. Whereas if you had a very high likelihood, and then by investing in this cybersecurity infrastructure, you would then be able to bring that likelihood of the hacking or attack lower, which would then save. In this case, it was particularly focused on downtime for repair and diagnosis, right? So when you're when you're trying to see what happened, whether it was like a bandwidth attack or, other type of unauthorized use, when you have to shut down the line, you're not making parts. You also have to factor in the cost of turning things on and off again, as opposed to running them continuously. So quantifying that amount. So from there, you could actually, instead of saying like, here's the amount of money I'm going to save, it's here's my ROI based on my likelihood of a breach before and after your security measures are implemented. So that's how we were able to kind of answer that question as best as we could. Like I say, in more I'll say more fundamental research based circles, you can just assume or like calculate some likelihood number, and then you get a nice firm answer. In a more production scenario, that's not as feasible. So that's kind of the way that we worked around to demonstrate ROI for the project.
So the benefits are clear from those for small and mid-sized manufacturers and participating in a project like this to help identify potential threats and protect against them. But Gabriela and Curtis, from CyManII's point of view, I imagine there's also a learning experience, and I think you both addressed some of this, but to help move forward and apply these to future projects. What came out of this project.
Oh, definitely. This whole project cycle was extremely beneficial for us, and we learned a lot. And we worked with both the small and medium companies, but also large ones. So we got to see both perspectives and requirements, and it will definitely help us move forward with the next RFPs. So that we can make the adaptation even faster and better next time.
Sure. I know we've covered a lot of ground here, but anything that we missed that you'd like to add from either Gabriela, Curtis, or Vinh?
I think we covered a lot of things, and I think again this was an extremely good experience for us, and we were very lucky to have the partners like Vinh working with us, and we are hoping that more and more of the results and the work that we are doing will be on other manufacturers' priority list, and we also hope to give access to all our papers. We also publish, given that we have a TRL 2 to 6, we also publish a lot. So there are publications that are coming out from our work, and the community has access to those, and we hope to get more interested parties for the next RFP processes.
Yeah, and I also kind of want to follow up with our experience working with CyManII. So as I mentioned before, I've worked and been in part of manufacturing USA institutes for some time now, and I do think that CyManII has something very special, particularly with their breadth of TRLs. Sometimes it can seem like someone made something and then you just kind of have to work with it, whereas or you're making something and then it's someone else's problem to see how that ends up being surpassing the valley of death in the TRL advancement. And I think that working with CyManII has been great, particularly because they're really focused on that wide range of TRLs to cover all of their bases there. And that's also exemplified by their wide range of people and networks as a part of the organization to advance kind of secure and cyber manufacturing.
Well, cybersecurity remains a critical topic for the manufacturing industry and of course, the world at large. So it's reassuring to know that organizations like CyManII and the very smart people like the people on the podcast here are there to help to work things through and help protect the rest of us. So where can listeners go to get more information about CyManII and potentially participate in a program like the one that Vinh was in?
We would invite them to go to CyManII.org. That's CyManII.org. And they can read more about ourselves and how they can join the institute as well. And then RFPs, whenever they are available, they will be posted there and they will be advertised. Our papers are also on our website, and we keep updating the list of papers. So there is a lot of material to look through there.
So Vinh, if people want to venture up to Houghton and find out more about Michigan Tech, where can they go to do that?
Yeah. If you want to come up to Houghton, you're welcome. You can, single-handedly double the population with just a few flights. But yeah, I think for us, we're a public university with the state of Michigan, so we have an accessible website there. The blueprint that came from this project is also available on SME's website. So that's kind of the more official documented version there. And then folks are also welcome to reach out to me directly. My email is public, so people can reach me at vinhn@mtu.edu, and I'm more than happy to have a conversation on CyManII and this industry use case.
Well, thanks again, everyone. And to learn more about the latest manufacturing trends and hear more of our podcast, visit advancedmanufacturing.org, which is also where the blueprint that Vinh mentioned is accessible. And be sure to like and subscribe to our feed.